Assalamu alaikum student. Today we discuss the topic of work and energy, that is the work. First we define that what is work in physics. Work work means using a force to move something. If you push or pull an object and it moves, you are doing work. The amount of work depends upon the three things. That is, one is the force you use. Second one is second factor that the work depend upon how far the object moves because of the force. In short word, we say that displacement. Third factor on which the work depend upon, that the third term is the direction of the force with respect to the direction of object moves. Formula is work work is equal to force into displacement. So we can write the formula. It has W is equal to F dot. The work is scalar quantity, so we use the dot product. So this is the formula of the work. We can write it as, if we remove the dot product, W is equal to F D cos theta. That is about the work. What is work? Now we discuss the types of work. There are two types of work. There are two types of work. First type is the work done against force. This happens when you push or pull something. Example: first example is an article pulling back a bowstring. Second type is a weight lifter lifting a barbell. Work against gravity. Now we discuss the second type of work. That is the work change the object speed. This happen when a force is used to make something go faster or slower. Slowing down a car uses force to reduce its speed. Now we discuss when the work is done. Work is done only when a force or a component of a force is parallel to a displacement. Here we take the example of card. When we push the card with a force F and move with displacement D, then the force and displacement are in the same direction, so work done is equal to F D. Now, if we move the card and we apply it force at an angle theta with the horizontal, then it move with displacement D, then we resolve the F into two components. Here we resolve F into the move displacement D in two components, horizontal component F cos theta and vertical component F sin theta. So we work is done only when a force is in the direction of the displacement. So which component is in the direction of displacement? F cos theta is in the direction of the displacement. So we multiply the component of force F cos theta into T. So W is equal to F T cos theta. And in short form, we can write it as W is equal to F dot D. So this is the formula of work done which we use. Now we discuss the positive, zero and negative work done. First we discuss the when the work is positive. The work done is positive if the force act on a body in the direction of motion. Here, if we push a card, so we displace the card in the direction of force. So force and displacement in the same direction. So here we can write as W is equal to F T cos theta. Here is the angle is 0 degree because both force and displacement in the same direction. So work done is equal to force into displacement into cos 0 and cos 0 degree, that is equal to 1. So here we write W is equal to force into displacement. So this work is positive. Positive work done. Now we discuss the negative work done. The work done is negative if the force act on a body in the direction opposite to its motion. So here, when the card is moving opposite of the force, then angle is 180 degree. So here we use work is equal to F force into displacement into cos of 180 degree, that is equal to work is minus force into displacement. This work is negative work done. Now we discuss the zero work done. Work done is 0 if force act perpendicular to its motion. Here we take the card, here is the displacement and this is the force. Both are make an angle 90 degree. So if they make an angle 90 degree, so work done is equal to force into displacement into cos of 90 degree. Cos of 90 that is 0. So force is equal to, so work done is equal to 0. So in this case, we say that here is the work done is 0 work done. So in this case, is 0 work done. Now we discuss the unit of work. Formula of work, that is equal to force into displacement. So in SI system, unit of force is Newton presented by N. Unit of displacement is meter, that is represented by M. Unit of work done is joule. So work is equal to force into displacement. So unit of work is joule, unit of force is Newton, and unit of displacement is meter. So in short form, we can write as joule represented by J, Newton is N, and meter is M. So this is the unit of work done. Now we discuss the unit of work, that the formula is the force into displacement in CTS system. In CTS system, unit of force is dyne, unit of displacement is centimeter, unit of work is arc. So we can write unit of work, that is equal to force into displacement, that one arc is equal to 9 into centimeter. That is the unit of work done in CTS system. Now we discuss the relationship between joule and arc. Here we know that 1 Newton is equal to 10 to the power 5 times 1 N is equal to 10 to the power 5 times. So 1 meter, that is equal to, here we discuss the 1 meter, that is equal to 100 centimeters. So in short form, we can write 10 to the power 2 centimeter. So here we use the two unit, Newton and meter. We know the formula, that of work is equal to force into displacement. So unit of work is joule, unit of force is Newton, and displacement is meter. So we can write joule is equal to Newton meter, and joule is equal to 10 to the power 5 times Newton is equal to 10 to the power 5 times, and meter, that is equal to 10 to the power 2 centimeter. So 10 centimeter, that is equal to arc. This we can write as 10 to the power sine 7 10 centimeter. So this 10 centimeter, we know that that is equal to arc. So this is the relationship between joule and arc.